And hello everyone, welcome back to another tutorial. So in this tutorial, we'll be taking a look at adding types to Lua. So this will just be Lua, but we're adding a bit of typing to it. For those of you who don't know, when you add types to a language, it's generally to make it static type, meaning when we say something such as let's create a new file, main.lua. If we go here and we say local x is equal to 10, this right here basically says x is a number. So Lua knows that x is a number. However, we could at any point go and say x is equal to 10. And then we can say print x if we wanted to. But the problem is, and you'll even see it here, this variable is defined as integer, cannot be as string. Lua doesn't like this. No language likes it when you do something like this, but you can. This will run perfectly fine. So if I were to just go here and say Lua main.lua, it still gives me 10 without an issue. But you should never do this. You should never actually have this happen, because it can later on cause issues in the code because you think it's going to be of one specific type, but when you take a look at it again, it's of a different type. So you never want this. Another use case is when you have a table or a function, but you're not always sure what that function is supposed to be doing, or what that function is, what it's supposed to be taking in, or how that table should look. And adding types to that can make it super easy. And that is where Teal comes in. Teal is like a version of Lua, but it has type support. Here we can actually take a look at its source code. As you can see, it is fully free and open source, and it does have good documentation. So I recommend you go take a look at it. In this tutorial, I'll kind of give you a basic overview of Teal and how it works and all of that. So first of all, you might want to get this Teal extension. I'll probably have a link to this in the description. If I don't, I just forgot, and you should just remind me. Next up, you want to install TL using Lua Rocks. I do have a tutorial on getting Lua Rocks to work on Windows if you do not. And take note, you do need to know at least a little bit of Lua. Do have an entire crash course on it, but knowing at least a little bit of Lua would help you with Teal, because we're going to cover basically only the Teal stuff. We're going to expect that you know Lua. Now we can just go here and we can say Lua Rocks install, and I'm just going to say -- local because I'm on Linux. So you can say Lua Rocks install TL. Now I already did this, so I already have Teal installed. If I go TL, as you can see, I do have Teal, and here it says a command is required. But once you install it, you should have a binary that can run. So you should be able to type TL in here, and if you go -H, you should see something similar to this. Let me maybe just resize this terminal a little bit. If you see something like this, then TL has successfully been installed. Now, let's create a TL file. I'm going to delete this main.lua. I'm going to create a new file called main.tl. Now take note, you can use TL files inside of Lua files if you have the TL extension installed, and we'll actually get to that. Or actually, let's do that. Let's actually create a TL file that will run inside of a main.lua file. So you can say script.tl, and we can create a main.lua. Now in main.lua, we can just say local TL is required as TL. Once you have that, you can just say tl.loader. And it will load TL files and basically compile it into .lua files that we can then use in our project. So let's say we have a script here that just goes, it has a function, and this function is called say, which takes in text, which is of type string, and we're going to go through all of this in a second. And in here we can just say return say, or not the need to return thing, we can just say print text. And actually we just need to specify global here at the front. So now Teal knows this is a global function. We want to use it outside of this file. It's just say, you could of course go like this, that should also work. And it will just print out the text we put in here. And I'll explain all of this in a second as well. Then in here, we can say local is C for script is equal to require script. And we can just say sc dot say hello. Now if we were to run this Lua file, Lua main.lua, and I think we should just say require. And we can just say as well. Now if we run this, we get hello. And say comes from this. So we can use TL files inside of this Lua file. We just need to say this and in this. But for our purposes for this tutorial, we are not going to use any Lua files, but if you wanted to, you could. Now let's stick with this script.tl. Now before we get to actually scripting, I would like to teach you about a few commands we can use in TL. So let's go here and say I am cool. And we can say and a number. You'll notice we do get an error here because this expects a string, but we'll get to that. Now a few commands you can use is TL check and then what you want to check, and this will check for any issues or errors inside of this file. As you can see, we get one error. It got an integer at line 6, so line 6, and it got an integer but expected a string. An integer is a number and a string is a piece of text. That is understandable. We can of course do that, and now that error will be gone. So as you can see, no error. You can then say TL run script, and this will run it just like a normal Lua file, just run it immediately. You can also go TL gen and then script.tl, and this will create a script.lua. As you can see, it just does this. So it's a script file, but it converts it to a Lua file. So if you need Lua files, you can convert your TL files to Lua files. Cool. So those are probably the ones you're going to be using the most. There are others, but they're not that important for our cases. Now let's get actually to learning the basics. So what is types? I did tell you all a little bit about this inside of my crash course, but basically types is just something that a variable can hold. For example, local x is equal to, and if we put this here, it's a string because it's in double or single quotes. If we put a number here, then it's a number, or in our case, an integer. In Teal, you have two types of numbers you need to be aware of: the integer and the float. Now, they have different types that we can speak of, and we'll get through all of them in a second. So they have any, nil, boolean, integer, which is just a number such as 1, 2, 3, -5, -6, whatever, it's a number. And then you have number. Number is like a floating point value. So it can be 1.2 or 5.1 or -4.1 or 9.0. This is a number and this is an integer. So one just has floating values. Then we have string, which is a piece of text, so voilà. And boolean is of course something such as true or false. Nil is nil, and any means any type, so it can be a string, a number, an integer, whatnot. And then you have thread. We're not going to really get into thread, but just know thread is a coroutine. So coroutine. But it's that type of a coroutine. You also have more complex types such as arrays and tuples, maps, functions, enums, records, and we'll be getting into most of them. So let's create a few basic functions. For example, local sum, which would be a function. Now sum will take in an x value, which would be of type number, or you could say integer. But this will be a number, so you can put floating point values in here. And it will take another value that's also of type number. So we use this colon to say what type we want, and then we specify the type. Same with a function, we want to return a number type. So now we have this sum function, and we can just return x plus y. And here we're getting a little bit of a squiggly line because it is unused. So it's telling us we should use this sum function or remove it. Otherwise it is unnecessary code. We can then say local x is equal to sum 20 and then 15.2. And if you hover over the sum, you see we actually get a great example of how it works now. We see we need a number, we need another number, and it will give us a number in return. When we do this, it says it's a number by default. So if you don't specify a type like this, it will infer it for you. So if we print x, then it will infer that x is of type number. So you don't need to specify this is of type number. But specifying it is of type number is recommended because when you go through the code, you immediately know what type you want to have here. Now, of course, if we were to run this, so just saying Teal script.lua, not .lua, I mean .tl, and it should be run. Then we get 35.2, about what you'd expect. However, now it is much easier to know what type you need where, what type you want to use. If we were to say TL gen script, then this script.lua, you'll see it is the same thing, but it is slightly less explaining. So we just go like this. You'll notice here we have a sum, and we can see it takes number. If we go here, it will say x is of type any and y is of type any, but it does return a number. So you will know x is a number. But Lua does not know what type x or y is going to be. So it says x and y is of type any. However, here we know x and y should be of type numbers. In a simple program such as this, you might not really see the use of this. But believe me, once you have a really big and complex program, having types can be very useful. Now take a look at this. When I say x is equal to a piece of text, you'll notice we get an error because you cannot set a string to something that should be a number. And that is what's happening here. X should be a number, but we're trying to set a string. This is what I was talking about with this should never actually happen. And here, it's forcing us to use good practice and never reassign the value of x to something else that is not of its type. We can still go x is equal to 23, it won't care. But we cannot say x is equal to a 23 in strings, because then it will be a string. Now let's talk about enums. They're one of the most useful types you can get in almost any language. So let's say local enum, so we're specifying we want a type of enum. And here we could say season. You could of course go season like this as well. It's up to you which type you prefer. And we can say end. And now we could specify a bunch of seasons. For example, we could have winter, summer, spring. And now we have a few seasons. So to give you an example, if we go here and say local x is equal to something and we only want it to be these specific values, we could say is of type season. And we can specify here a type. So this could be summer. That is allowed. But if I say summers, you'll see we get an error because summers is not part of this. We say summer, it is. So it's almost like creating your own types. That is why you could also say this local here. If you say type season is equal to enum, then it is allowed to do this because enum is on its own type. However, you could simplify this to just saying local enum season instead of local type season is equal to enum. Now, some of you might already see a bunch of uses for enums. And believe me, there's a lot of uses for enums. In almost all of my programs I write, I usually use enums. Just because of how flexible and useful they are. Now back to something more basic. If we were to do something such as local x, we'll actually get an error. Generally in Lua, saying something such as local x is perfectly fine. Lua doesn't care if there's just a random variable laying about. However, in TL, it's something different. Here we don't know what the type of this variable is, so we don't know what we want to store inside of it. We can then specify this should be a string. And like that, we don't really care anymore, but we do know that x here could be a string. Alternatively, we could also say or nil. Now we know that x can be either a string or nil. So if I say x is equal to this, it's allowed. If I say x is equal to nil, it's allowed. But if I say x is equal to 40, it's going to yell at me and say, what is this? Why is x equal to 40? 40 is not allowed. So here you can see how you can actually specify two types something may be. So let's say you want a string and a number. Now, x can be either a string or a number. In this case, x is still equal to be nil, because generally you can expect some variables might get deleted and be nil. But now we could go x is equal to 203. That is perfectly fine, because x can be either a string or a number. If you want to declare a bunch of variables like this, where there's no actual initial value, you could do x, y, z is equal to, or let me just say colon, number, string, and here we could say boolean. And now all of these will have their values that they can be. So if we say z is equal to 5, it's going to say no, because z should be a boolean. Y should be a string. X should be a number. And you can also give them all initial values like this, so you can still put things on the same line. And in here you could do something such as print x. That's perfectly fine. And if we were to actually generate this just to see what script we're going to get with Lua, you'll see we get the same code, but here it just doesn't have its types next to it. It's just inferring the types as usual. Next up, we can take a look at arrays. Arrays are tables. So if I say local friends is equal to Jack, Mike, this is a table, but in TL, this is an array. So we can actually go here and specify string. So this array can only keep things of string type. So if we try and go and say this should be 349, this will not be allowed because this array is only allowed to hold strings. We could go string or number, and now numbers are allowed. And does work the same as with normal tables. So this here is still allowed, friends at index 1. If I were to run this, we'll still get Jack. It's a normal table, but now we say this table is only allowed to hold strings. Next up, you can have tuples. So a tuple is somewhat like a key value pair, but not quite a key value pair. For example, here we could say local Jack is equal, or let's say local friend is equal to Jack, and he's 29. This is a tuple. So now if we go print friend, then it will work as a tuple. This is similar to saying string integer. So this can hold a string value and then an integer value. If we were to go here and say 9, it will actually throw an error because you cannot add another thing here. You might be able to by going number, and that will add another thing. But a tuple is generally two things, but if you want to specify the length that it should be as well as the types it should hold, then this is the best way to go. Here you could even possibly put an array. So now this tuple should have a string and then an array inside of it. But take note, it's still a regular table. So if we go at index 1 and we run it, we'll get Jack. It's still a regular table, but now it actually defines itself as a tuple. Then maps are very similar. Maps are actually key value pairs. For example, let's say we have friends again, and friends can be a string for the name and then a number for their age. Now if we go here, we can say Mike is 23. However, we should take note that Mike here should be inside of brackets like this. This is just because of how Lua is made, so you can't just say Mike is equal to 23. That will confuse Lua. This does not confuse Lua. And in here we could of course say Mike. So friends at Mike. Now if we were to run this, we will get 23. And of course you can have as many of these as you want. So if we could go, and Nick is 99. Pretty old guy. You can put almost any type here. You could even put a boolean, so boolean. And now we could do something such as true and false. That is perfectly fine as well. I wouldn't actually ever recommend you do anything like this, but now we can say true. If we were to run this, we'll get 23. If we were to say false, then we'll get 99. So you can do this if you want. Now, records are probably one of the best ways to actually say how something should look. For example, let's say we have local record, and this is like creating your own type again, but more like a table type, like an object. And here we could say friend. So this is how a friend should look as an object. They should have a name, which is a string. They should have an age, which is a number or an integer, would actually be better for an age because number can have floating point values. And then we could maybe have something such as best friend, which is a boolean. And this just defines how something is going to look, how an object will look. Now if we go here, we can say local Mike is of type friend. And here we can just specify the name is equal to Mike, the age is equal to 34, and then the best friend is equal to true. So this is a way to get into object-oriented programming without having to have all of the confusing things that goes with it. So I would actually go and say friend type here. Once you have friend type, you can say local friend, local function friend, which will return a friend type. And here you could even pass in something such as the name, which is of type string. And in here we could return a function or an object name is equal to the name that's passed in. And just to make it uname so we actually know what we're looking at, we can just go uname. And here we could have age, which by default will be 10 or something, and then best friend, which will be false by default. Now we know when we create this object, so local Jack is equal to friend Jack, we know we are getting a friend type. So here Jack is of type friend type. So we know we can go print Jack dot, and here it gives us everything we need. We can go jack.name, we'll get Jack dot best friend. And here if we run this, will get false because he is not a best friend. And of course, if we were to generate Lua code, then you'll notice there's not actually a record there. It's just an open empty space where then we have this. And this is very powerful because it can make almost all of your code 100% easier to read, especially when you get into OOP. Because OOP, when it gets really big, can be so confusing, whilst this can make it 200 times easier. And this is the basics. There's of course a lot more. You can actually go look at the docs. So here we have a bunch of the docs you can look at. And you can actually take a look at it. I think this is one of the best things to happen to Lua, is to have something such as Teal, where we have Lua, but it is more than just Lua. It is so much more. And you can just, with all of this typing and things, your code will become so easy to read, it will be scary. I 100% recommend you start using this in your projects, because I definitely am. If I'm going to write Lua, I prefer to write it in something that gives me types. This is why I prefer Nim over Python, because Nim is like Python but with types. This is why I like TypeScript over JavaScript, because TypeScript is like Teal for Lua but TypeScript for JavaScript. And yeah, thank you for watching. I hope you all enjoyed, and I'll see you all again in the next tutorial.